This one I combine E and F together for absolute maximum and absolute minimum and local maximum and local minimum problem. Have a think about that. Like I talk about that at the very beginning of this chapter. How can you find out absolute maximum or minimum? How can you find out absolute maximum or minimum? Or change a way to ask it. Where it will exist, among which points the absolute maximum and minimum will exist. Do we remember that? Anyone? Give you a hint. Well, it's either in stationary points or where? Stationary points is turning points. Endpoints. And points. Okay, it's either stationary points or endpoints. So the absolute maximum and minimum must exist either at the endpoints or either on the turning points or stationary. It can't really be stationary point of inflection, but when you solve stationary points, you will solve out stationary point of inflection. But you don't need to care about that. So I will just evaluate my endpoints and then find dy dx equals to 0. And find the coordinates for stationary points. So among those points, you will definitely find out which one is the highest, that's the maximum. Which one is the lowest, that's the absolute minimum. Okay, so that's where your absolute max and min will exist. Okay, only at those positions. It's not going to be anywhere else. It's either turning point or stationary endpoints or stationary points. Only at those two places. Okay, the next thing we asking is for maximum and minimum problem. In the application question, when it asks you what is the maximum of something, or they ask you what is the minimum of something, the only way to do this is make dy dx equals to 0. Is find the stationary points. Okay, is find the stationary points. It's not 100% right, because when I'm asking for maximum or I'm asking for minimum, we use the same method to solve. Do you know whether I solve out maximum or minimum? Or think about dy dx equals to 0. We will have stationary point of inflection be solved out as well, right? So, but what we will solve out stationary points, then we need the sign check. Okay, the sign diagram check, the gradient check. We need to check it to see whether we get a maximum or we get a minimum. But the question normally is quite generous to you. If they ask for maximum, the dy dx you solve out will be a maximum point. And then if you ask for minimum, the dy dx you solve out will be the minimum. Normally they give you like that. They give you exactly what you need. Okay, otherwise you can't do it any other way. But, okay, so make this clear. In the exam, if they ask you what is the maximum for the area, for example, the area according to the x, we make dA dx equals to 0. We solve out what is the x. If the question doesn't say, verify the answer you solved is the maximum, you don't need to do the sign check. You just assume what you get is right. Okay, because normally questions are very generous. They just give you what you need. The dy dx you solve out will most likely to be the, well, it will, if they doesn't ask you, you need to show this, then the thing you solve out will be correct. Okay, they just want you to know like the maximum or the minimum is using derivative equals to 0 to solve. But for some question, they will ask you, use the sign like or the gradient diagram to check the answer you solve out is correct. Then you need to prove, well, use the 3-row thing, okay, to see, okay, x dA dx and graph of original and put the point in to prove that it is the maximum. They will explicitly ask you to use the sign diagram to check or not. But if you solve out 2 points, when you put dA dx equals to 0, you solve out 2 points, you don't know which is the maximum, which is the minimum, right? You can either put into the calculator to check whether you get a maximum, which one is the max, which one is the minimum. Or you can just use the sign diagram to prove which one is the max, which one is the mean, and then answer the what is required. Okay, so that's about how to answer maximum or minimum type of question. Because I realized last year towards the end, okay, we finished this like later. Students do the application question. They always come to ask me how to do the maximum, what I can do for a maximum, and what I can do for a minimum, or even it's in the part 1 exam, what I should do. I don't have the calculator, I can't graph this, like where is the maximum? Quite surprised me. Then I think this year maybe emphasize it here. Maximum and minimum question is solved by dy dx equals to 0. If they ask you to prove it, you use the sign diagram to prove that's the max or the mean or even the stationary points. Otherwise, you can just assume the only solution you solve out is the maximum or the minimum. If you solve out 2x values, then you need to use some way to find whether it's the max or the minimum. Okay, that's the way of doing max or minimum questions. Okay, so that's everything we have to say before the questions, and let's have a look at the questions here. Okay, given that x plus 2y equals to 4, calculate the minimum value of this. Okay, the minimum value of this. Let's make value equals to x squared plus xy minus y squared. If you want to use derivative, you need to have like equation, okay? Derive that equation, derive v equals something. So we just create a variable. Let's make v equals to that. The value equals to this. And I want a minimum value, okay? A minimum value when I change x and y values. But because x plus 2y must be 4, okay? X plus 2y must be 4. So I can change it all to 1 variables. Okay, we make it 4 minus 2y. I can't derive with 2 variables, so I must change one. Okay, x squared plus xy minus y squared. I replaced all the x by 4 minus 2y. Now I need to rearrange it. I can say that's 4y squared minus 16y plus 16 plus 4y minus 4y squared and minus y squared. Oh, sorry, just 2y squared here. Then we have 4y and minus 2y and minus y, so we have y squared. We have y squared here. Minus 16 plus 4y, that's a minus 12y. And plus a 16. Minus 12y and plus a 16. What kind of relationship between v and y? What's the type of relationship? V equals to y squared minus 12y plus 16. What's the name of this function? What's that? Cubic? Quadratic. Okay, that's a quadratic. Is that a happy quadratic or sad quadratic? Happy quadratic, then we will have minimum turning point. Okay, we will have minimum turning point. So this question after this, okay, this question can be done either by derivative or you can complete the square. Okay, or you can complete the square to work out that. So if we use completing square, v will be y minus 6 squared minus 36 and plus 16. V equals to y minus 6 squared minus 20. So the turning point is 6 comma negative 20. Okay, turning point, the minimum turning point is 6 comma negative 20. What you should answer for this question? What is the answer for this question? You can't leave your answer like the minimum turning point is 6 negative 20. You need to answer the question because it's application. What's the final answer should be? Do we need to sub into the equation? What's the turning point? What kind of graph is that? It's y and v graph, right? Y and v graph. And we have something like this. Well, I don't know whether the x-intercept is right or not. That's 6 and minus 20. Can we directly see the minimum y value, v value? What is it? Yeah, negative 20. I don't need to sub that back again. So v minimum is negative 20. Okay, v minimum is negative 20. So remember to answer what is required. Okay, so this question a lot of students only answer y equals to 6. Yes, y equals to 6 will give you the minimum, but what is actually the minimum value? Okay, so you need to give the minimum value. So v minimum is negative 20. Let's skip example 2 first. Let's have a look at example 3. Let's have a look at example 3. Just show you how to find the absolute maximum and absolute minimum. Okay, just a way to find absolute maximum and absolute minimum. So give your equation here. Okay, we can use calculator for that one because the number is not very nice. Just start the calculator. Okay, give you a function, a cubic function. Okay, hard to factorize. I don't want to factorize that, right? Or there's no point to factorize that. It asks you find absolute max or absolute minimum value. Well, you can graph it and then find point and look at the graph, which one should be the max, which one should be the minimum. But it takes a while to do it. Okay, it takes a while to do it. So what I can do is I know maximum and minimum can only exist when either at the stationary point or at the end points. So what I can do is directly do the calculations. 2x cubed. Okay, I will define this function first. 2x cubed minus 4x squared minus 22x and plus 24. So let's say that's fx. That's fx. Fx is that. Now we have endpoints negative 3.5 and 4. So I'll put f bracket negative 3.5. So negative 33.75. Okay. I will write down this one. And for 4, f4 equals to 0. Okay, that's the other endpoint. Let's keep substituting things. That's the two endpoints. And I will make f dash x to 0 to solve for stationary points. Okay, I'll solve for stationary points. Let's add the stationary points, all the endpoints. So I'll put f dash x equals to 0, solve for stationary points. Okay, well, a quick way to do this is menu 3.1 to directly solve. Shift minus directly give you the derivative sign. D dx of fx equals to 0, comma x. Okay, that's what I'll do. Derivative equals to 0 and solve for x. Okay, so I rather derive it first and put into the equation. I put in one line. Derivative equals to 0, solve for x. Enter. We have those two values. Okay, they are exact values. They are exact values. That's the x value of the turning point. Okay, it's the x value of the turning point. First of all, I want to see whether they are all in the domain. Okay, whether they're all in the domain. Well, negative 1.3 is in the domain and 2 is in the domain, so no problem with that. Okay, it's in the domain. Now I will use f bracket, this one, to see what's that. Well, control and enter. Have 41.49. Okay, 41.49. Let's just leave two decimal places. 41.49. So x value is negative 1.34. So negative 36, comma 41.49. Okay, that's the turning point. Okay, or stationary point inflection. I don't know. That will be one thing. And now another thing we will have is f bracket of this value. Okay, control and enter. That gives me negative 25.19. So the x value is 2.69. Negative 25.1944. So that's the two stationary points I can find from the cubic. Okay, from the cubic. So we have two endpoints. We'll always have two endpoints. And now we have two stationary points. Okay, point A, point B, point C, and point D. Which one is the highest? A, B, C, D, which one is the highest? Which point? I need the answer, everyone. C is the highest because it's 41.49. So absolute maximum will be this one. Okay, that's the absolute maximum. I think it will be a maximum turning point. Okay, maximum must be the turning point. So it's from the stationary point inflection. It can't be a minimum turning point. So it must be a maximum turning point. So it's 41.49. And which one is, okay, this is the absolute max. Okay, which one is the lowest? Which point? A, B, C, D, which one? A. Okay, A is the absolute minimum. Okay, absolute minimum. That's the way we use to find maximum and minimum. We just need to find, I don't need to worry about the shape of the graph. I don't care what type of graph is that. You just substitute points in, solve for stationary points, and compare all of these points. Doesn't matter what type of cubic or polynomial, exponential, logarithm, all use the same method to solve. Or even unfamiliar graph. Okay, or unfamiliar type of graph, you can still use the same way to solve for it. Okay, so that's the max and min for that. And if we can go to the top question here. Okay, this is with a little bit diagrams here. So a shelter is made up with a back and two square and the top. Okay, a back, that's the back, that's the top, and the two square at the side. Okay, so the total area of this is 24 meters squared. Let V be the volume enclosed by the shelter. Find the dimension will create the largest possible enclosed volume. Okay, let's change this question a little bit. Let's change A to the end. Let's do B and C first. Okay, let's do B and C first. Because we need to think about the domain first and then think about the maximum or the minimum. It's not in a good order. So let's sketch the V against X for a suitable domain. Well, before we sketch it, we need to write equation for it. Okay, we need to write an equation for it. So let's make an equation for V. V V needs to equals to x squared times y. Okay, that's the volume. It's really easy to write the volume. But I can't have y in the equation. So how can make y in terms of x? How I can make y in terms of x? What I should do? How can I set up an equation in between x and y using the total area? What should equals to 24? What should equals to 24? Have a think about that. It's 4 pieces of area. Okay, it's 4 pieces of area. Okay, we have 2 squared. What else we have? 2xy. Okay, we have 2x squared and 2xy. So 2 of the circle here and 2xy for the top and for the back. Okay, 2xy equals to 24 minus 2x squared, and y will equals to 24 minus 2x squared over 2x. Y will be 12 minus x squared over x. Okay, that's y. That's y. So V equals to x squared times y. V is x times 12 minus x squared. V equals to, let's say, minus x cubed plus 12x. Okay, I want to find a suitable domain. Can anyone give me 2 inequalities? Can help me to work out the domain? Like what restrictions you can have for x? Well, obviously x can't be too large. If x is 100, 1 piece of x squared is already 10 to the power 4. In total, we have 24 square meters. I can't have x too large. Okay, I need to leave something for the 2 rectangle as well. So what kind of 2 inequality you can give me to solve for the domain? Anyone? I need you to make me think. Anyone? I'll wait until anyone give me an answer. What greater than 0? Yep. X is greater than 0, or how do you get the square root 12? Yep, so we work out that one. But the actual, where we get that, it should be y greater than 0. Okay, where we get that should be y greater than 0. And then we're trying to solve for this inequality to be greater than 0. We times x to that side. The sign won't change because you know x is greater than 0. Okay, you know x is greater than 0. So what we solve now is 12 minus x squared will be greater than 0. Trying to solve for that one. And x is actually in between this area. Okay, x is actually in between negative square root 2 and square root 12. Okay, negative square root 12 and square root 12. Okay, it's actually in between that. But because we have the restriction x greater than 0, so therefore x is in between, that's 2 root 3. Okay, square root 12 is 2 root 3. So the x will be in between this area here. And you know, like, this is a cubic graph. If we factorize that, it's a square root 12 plus x and square root 12 minus x. If we say square root 12 is here, and we have x equals to 0 as well, negative shape, negative shape. Okay, we have that. But because the domain is only 0 to 2 root 3, so we have open circle here and open circle here. That's this graph. Okay, so that's 0, 0, and that's 2 root 3, 0. Okay, 0, 0, and 2 root 3, 0. Well, where's the turning point? I don't know yet, because I need to find the derivative equals to 0 first, and then solve for that. But that's B, okay, that's B. That's the graph. How do we get this graph? We think about the total shape, the whole shape first, and then we take the part we need in between 0 to 2 root 3. Well, C says find x, y values which give you V equals to 10. You can use calculator to solve for that. V equals to 10 minus x cubed plus 12x equals to 10, comma x. Well, it's not exact values. So we take the part we can have. Well, the first x is negative. Definitely we won't have this. But the next x is in between 1 something, that's fine. Okay, this one is fine. And the next one is fine as well. Okay, 2.9, that one is fine as well. So remember what is y. Y is 12 minus x squared over x. Okay, that's y. So I'll make it control var yx. Okay, and say that's yx, that's y in terms of x. So now what I need is y, comma, well, you shouldn't save y, okay? Because x and y is the variable you use the most. When you do it, you shouldn't save y as a function. You shouldn't define this y here. But like, I just want to use this one now. We can copy that, put that in, that's the y value. Okay, when x equals to that and y equals to that, give you the volume equals to 10. And don't forget, you have another one, y bracket 2.91, that one works as well. We have 1.16 for the x, y values. So when x equals to that, y equals to that, volume will be 10. When x equals to that, y equals to that, the volume will be 10 as well. So that's the 2 points. You will have volume equals to 10. And it does make sense why it should be like that. Because if we drop that's 10, okay, that's V equals to 10, we will have two intersections. Okay, we will have two intersections here. So that's why we solve out two coordinates, like two xy, two pairs of xy's. Okay, so C is given in the calculator, no space for me to write. You can just copy the values down. It's basically through calculators. There's no hand approach because it's not really some value nice to solve by hand. And we left A to solve. A asked me the dimension of the shelter that create the largest possible volume. Okay, the largest possible volume is when dy dx equals to 0. dv dy equals to 0. You can see we have maximum. Because we already have the diagram, we see there's a maximum turning point. So dv dx equals to minus 3x squared plus 12. So minus 3x squared plus 12 equals to 0. X squared minus 4 equals to 0. And x will be plus minus 2. Okay, but because x can only be in between 0 to 2 root 3, so x equals to 2 only. So this coordinates is 2, comma, okay, I think it's f2. No, f is not that. I need to sub by myself. I sub 2 in, negative 8 plus 24 is 16. Okay, 216 is the maximum volume here. 8 and 24, yeah. So actually the shape should be a little bit, okay, that's 2 root 3. A little bit to the right, okay, a little bit to the right. The turning point is a little bit to the right. So it's 2, 16 is the maximum volume. Okay, that's this question here. Well, the difficult part is to find the domain and find the proper shape. Okay, but you always need to set up like 2 equations. One is the equation involves 2 variables, and the other equation is change one variable into the other one, and then we can just calculate that. Okay, we can just calculate that. We can use derivative to solve. Well, also you not necessary to do sign diagram anytime. When you have the graph, you know that you have a maximum. In this case, the turning point you so far, the derivative equals to 0. You only have 1 point. That point must be this, refers to this turning point. So it's something already you know. You don't need to use a sign diagram again to test for it. So it's given. Okay, it seems like given. Alright, for example 4, you can try that by yourself. It's not a hard question because well, it's the same theme every time. I'm a little bit bored with it, but you need to be careful. Sometimes, okay, sometimes, well, this is the absolute maximum question. You need to try it now. Sometimes the stationary points is not in the domain. Okay, it's go out of the domain. It's not in the domain. This question is that type. Okay, this question is that type. You can see stationary point is go out of the domain, and which means you need to figure out what is your maximum. Okay, your end point might be your maximum now. So you don't have turning point in the graph even. So you can try this question now and you can do revisions. Tomorrow we talk about something about motion a little bit, and that's it.